Our course name System Design Control. Today we are going to see about block diagram reduction techniques. Myself Dr. M. Ravi, Professor Mechatronics Department. Introduction about block diagram reduction. It is a block diagram is a pictorial representation of cause and effect relationship of a system. The interior of the rectangular represent the block usually contain the description of the name and element, or the simple of mathematical operation to be performed on the input yield. The arrow represent the direction of information of the signal flow. The diagram shows the blocks. The operation of addition and subtraction have special representation. The block becomes small circle called as summing point with appropriate plus or minus sign associated with the arrow entering in the circle. The output is the algebraic sum of the input. Any number of input may either summing point. Some blocks put a cross into the circle. Here we see the example for the summing points x and y as a plus x plus y. Next, x as an input, y as y also the input. The sign is minus x minus y. Here x plus y plus z, it is called as a summing points. Next, in order to have a same signal or variable be an input to more than one block or summing point or takeoff point to be used. Here the example for the takeoff point, this permit the signal to produce along the several different path of several destinations. Here the example for takeoff point, here the dotted line is called as a takeoff point. We are using number of inputs, so we are using takeoff points. Consider an example 1. The following equation x1, x2, x3 are the variable and a1 and a2 are the general coefficient or mathematical operation. Then x3 equal to a1 x1 plus a2 x2 minus 5. We represent as a block a1 x1, a2 x2, a5 as a input. We are getting the signs in a summing point. The final output is x3. We are putting the a1 as a block as a signal. Consider the following equations: a1 x1, a2 x2 minus 3. a1 x2 or a2 are the variable, x1 x2 and 5 as a input. Therefore the summing point output get as a x3. Consider the following equation: x1 x2 up to xn are the variable and a1 a2 up to an are the general coefficients of mathematical operation. Then xn we represent a1 x1 plus a2 x2 plus an minus 1 xn minus 1. We are representing the block. Consider the input x1 x2 up to x minus xn minus 1, a1 a2 an minus 1, finally xn as the output. Example 3. Draw the block diagram of the following equation. You take as the homework a conical form of feedback system. This considers a closed loop control system. G is the direction transfer function, forward transfer function. H is the feedback transfer function. GH, we represent GH as a loop transfer function, open loop transfer function. C by R is a closed loop transfer. We already know C by R is a transfer function of the output G divided by 1 plus G into H. It is we are representing plus or minus signal. Here plus or minus represent positive feedback and negative feedbacks. Error signal E by R, actuating signal ratio E by R is equal to 1 plus or minus GH. BR is the primary feedback ratio. B by R is equal to CH divided by 1 plus CH. Next, the characteristic equation of a control system. It is a closed loop control system characteristic equation CS by RS, that is a C of S divided by 1 plus G of S into H of S. The denominator of a closed loop transfer function determines the characteristic equation of the system. which is usually determined 1 plus g of s into h of s equal to 0. Examples: it is a reduction techniques. We are seeing this class, we are seeing block diagram reduction. So reduction techniques, there are 9 rules. First one is a combination of block in cascade. We are converting G1 and G2 in a cascade. It is a G1 G2. The combining blocks in parallel G1 G2 in plus, therefore G1 plus G2. If it is signal is minus, it is G1 minus G2. Moving point beyond the block, that is we are moving the block beyond the block, we add G. Next, moving pick off point beyond the block, we add 1 by G in the block. And moving pick off point ahead of the block, we add G before the block. Eliminating the feedback path, it is a closed loop transfer function, therefore h is the feedback function, therefore G into h, it is G divided by 1 plus G into plus or minus G into h. If h is 1, G divided by 1 plus or minus G. Swapping the two neighboring summing points, we are interchange the summing point one to other. For example of reduce the block diagram in conical form, it is a conical form means the combine all cascade using the transfer function, that is we already know that G1 and G4, it is a G1 G4. Here conical form, first reduction form G1 and G4, it is in conical form or in cascade form or in series form, it is a G1 G4. Next, combining all parallel blocks, that is a G1 plus G2. Eliminating all minor feedback loop using the transformation, that is G1 G4 feedback is h, therefore G1 G4 minus 1 minus G1 G4 h1. Shifting the summing point left takeoff point right to the major loop using the transfer function. However, the example 4 does not apply. Repeat the step 1 to 4 until the conical has been achieved the particular input. For the example 6, for the system represent the following block diagram determines open loop transfer function, feedback for transfer function, control ratio, feedback ratio, error ratio, closed loop transfer function and characteristic equation, closed loop poles and zeros, its k is equal to 10. We reduce this block as first we reduce the given block diagram in conical form, that is k is reduced by k divided by 1 s plus 1, that is k is multiplied. Next, s as a feedback function. So s equal to feedback function g divided by 1 plus g into h, that is equal to k divided by s plus 1 divided by 1 plus k s plus 1 into s. Next, point 1 as a feedback function. It is an example for example 8 function block diagram reduction. Here we reduce the first step as a takeoff point moving to the next position. Therefore, we are h2 by g1. We are adding g1 in denominator. Next, g1 and g2 as a cascade function. Therefore, we are multiplying g1 and g2. Next, moving this shifting the summing point 1 and 2 and reduce the feedback function h1. So g1 g2 divided by 1 minus g1 g2 h1. Here g3 as a cascade, therefore we add g3. Finally, we get g1 g2 g3 divided by 1 minus g1 g2 h1 plus g2 g3 h2. Here one feedback function, so we are adding the feedback function as a feedback as a 1 g1 g2 g3 1 minus g1 g2 h1 plus g2 g3 h2 plus g1 g2 g3. Thank you.